On the bench today is a beautiful wooden case Luxman R1050, and I think this is going to be a fun project in service today because the customer wants it fully serviced. He wants me to clean all the potentiometer on here. He says they're a bit scratchy, and probably they are. All the switches as well. The guy says that he's not getting the lighting that he kind of wants. He thinks that I may have to change some bulbs, and I'm going to check that as well. We'll hook it up on the scope and see if we have equal channel on these. This is pushing 55 watts, by the way, so this is pretty powerful. So if you have a Luxman R1050, this video could be an interesting video. On this particular Luxman, the bias is set a little different, and we're going to go through it on this video. So if this is something that is interesting to you, this could be a good video to watch, and we're going to do it right now.
It's a long way.
Power it on. It doesn't look too bright on here, but maybe that's the way it's supposed to be. We're going to hook up a frequency of 1000 hertz on here, and we're going to find out what it sounds like. There you go, 1000 hertz. Let's do it. Sure, the volume is up on this, and here's my volume. And there it is. Now I will mute this. And let's see what kind of wave are we getting. Okay, I'm plugged in the dim bulb, so I'll change that because my dim bulb is not going to be able to take this. There we go. Okay, got an unseen wave. This is at 10 volt per division. I have distortion at 24 volts. I'll kick her back down. I'm down to 22.4. But I do notice that one channel's at 2120 and the other one's at 2240. I do have a bit of difference. But anyways, we're going to investigate this a little more. You can check all these lights. Alright. I'm going to shut it off. And I'm going to take this out of the box. Okay, look at this. How this is well made, eh? Look at the size of this heat sink. Wow. This is my phono amp right here. We're going to check some of these capacitors. What I'm going to check right now is I'm going to check some voltage. Always like to do the voltage thing before I start anything. Okay, so I'll power it on again. And there, it just clicked in, so the light is off. So it did take a while. I'm going to do it again. We'll count it. 1, 2, 3, 4, 5, 6, 7, 8. 8 seconds before the relay kicks in. There's the relay right here. Dandy. So let's check our voltage. My minus 48, plus 48, 48, and minus 48. These output transistors are working well. Okay, this is a schematic of my power supply, and here's my transformer. divided in 4 phases. This is my secondary winding here. So if you look at pin number 11 and 13, should be AC volts, and this is coming out of my transformer. So I'll measure that voltage with you guys. I mean, it's plugged in, and I'm going to measure pin 11 and 13. Here is 13. I'm getting 36 volts. This is AC voltage. My next pin is right behind it, 36.24. This is AC voltage, okay? It has to go through this rectifier, and I'm gonna be checking pin 12 and 14. That should give me 48. So I'm getting some voltage, but it's also changing AC to DC here. So pin 12 and 14 should be 48. So I'll change this to DC, and these are the 10,000 microfarad capacitors. Should be measuring 48 volts, and which I am, 48.75 and 48.7675. The Luxman R1050 wants 48 volts at the output. It's exactly what I'm getting, 48 volts. Now we're going to continue on. This thing is pushing 55 watts per channel. Look at the size of the transformer. Isn't that beautiful? It's really well laid out. There we go. Look at the fuse in all straight line. This fuse here doesn't belong there. He replaced it. I'm sure it's the same value. Hopefully. We'll look at that. Look at this. I don't have a lot of lighting for the front panel though. I think I'm going to look into that. Okay, right there's a potentiometer, and attached to it is a circuit board, and it's something that I will be checking closely. It has capacitors that could be high in ESR or out of value. That could cause a discrepancy between the right and left channel. And the volume pod could also be dirty as well. So I'm going to investigate that closely, and we'll also do a bias check as well. Since I have discrepancy between the left and the right channel, a little bit, not by much, we're talking about 1.2 volts. I want to investigate this board here, so I'm going to take the volume button off, and I'll put a deep socket there. This is the 11mm socket. There, it fits perfect, and there it is. Loosen this up. Then after that I should be able to take that little circuit board out of there so I can investigate a little closer. There we go. It's a tight squeeze. The volume potentiometer could be just dirty as well, so I'll just spray some contact cleaner on that. That cap is really loose. I can probably just pull it out. Yeah, there, pulled it out. This is a 100 microfarad at 50 volts. I'll be checking that for sure. Oh, that's where the 100 microfarad capacitor came out. These two little tiny holes here, I never even unsoldered them, they just popped out. There, I've replaced the 100 microfarad capacitor with a new one. Maybe that'll make a difference. We'll give it a test anyway after I'm done soldering this. So I am going to spray now that I have it out. It to change the channels. I have a lot of static and scratchiness, and this is probably due because this has been, you know, stored for a long time, and the accumulation of dust in between the rotors here. I'm just gonna put in, I got a soft brush here that I'm gonna brush things off. Actually see the dust flying out of there. Whatever you do, don't spray anything on here other than air buster. You clean it with a soft brush, and here's a can of air buster. And that's going to help a great deal. Okay. I'm at the idle adjustment. And this is what I'm going to try to attempt to do with this Luxman R1050. It is a bit different than what I'm used to. I'm used to measuring millivolts between the emitter resistors, and then you can adjust the idle adjustment that way. But they want us to do it differently. Instead of millivolts, they want me to measure this in milliamp. So in order to do this, this is the P1062. This is the board here, 1062, and this is where you'll do your adjustment. And I have tried with my multimeter. I put it on to milliamps, but by hooking this up like this, the relay doesn't kick in, so I can't really adjust nothing. So I figured I'd go another route. I'll go the way that they want me to do. And okay, I'm ready to set the idle adjustment on this Luxman R1050. It's a bit different than what I'm used to. I'm used to measuring across the emitter resistor, and that gives you the millivolts and use. But this Luxman is asking for 50 milliamp. They want me to get an amp meter that measure milliamps, and which I do. I have that here. So I'm going to attempt to do this with this Luxman. Okay, so I need to take the fuse F102A, and this is the one on the right, and F102B, which is going to be for the left channel. I'm going to do the right channel first, so I'm going to do this one. So I'll remove this fuse. And of course I have no power to this. There's no power here. Okay. Now I need to hook up my amp meter that measures milliamps on the fuse grip. fuse grips are polarized, so you need to be careful with this, okay? So plus is here, and this is the negative. So I'm going to do that, but before I do this, I want to show you guys what I'm going to do. I'm going to also hook up my multimeter across the emitter resistor. I'm going to measure those at the same time I'm measuring for milliamps. Change my clamps to these little clips here, and of course, like I said, I don't have any voltage on here. Just going to measure the right channel first. So across my emitter resistor, so I'll put this here so we can see. And now I'm going to hook up my amp meter on the positive, negative on the negative, and I've got a piece of tape here that just going to put it here because I want to separate this a little bit. I'm kind of afraid that this is going to, I don't want this to touch over and create a short. Okay, so I'm all set to test the milliamps from the right channel, and as I'll be checking the milliamp, I'll also be checking across the emitter resistor, and that should give me my millivolts. A lot of questions about this receiver where they're asking, hey, I'm not sure where to set my idle, or how many milliamps should I set it to, or how many millivolts should I set it to. So this way here, if I set this to 50 milliamp, that'll give me my millivolt across the emitter resistor, and that should give us, and then we'll be able to compare for an amp. It's not everybody that's got an amp meter. And why would you get one if you're only going to use it once in your lifetime? So if you don't have one, that means you'll probably never use it again. So right now I'm going to power this on, and we'll see without the fuse if the relay kicks in. Got power to it. My relay is blinking, so it's thinking right now. Oh, it kicked in. And check out my milliamps. My milliamp meter is running as well. How many millivolts? So I'm going to turn this on to millivolts. And as this thing warms up, like right now I have 11.1 millivolts across the emitter resistor, and I am at almost 30 milliamp across the main fuse on the right side. Okay, so as this warms up, I'm going to zoom you guys in. Potentiometer VR101A is for the right channel. VR101B is for the left channel. So we're doing the right channel. Just going to do one channel at a time. And I need to bring this to 50 milliamp. Okay, so that's what I'm going to attempt to do. Keep that in mind. 50 milliamp. And then we'll be able to check how much at 50 milliamp, how many millivolts do I get across the emitter resistor. Okay, so that's my main goal with this video. So I'm going to start to adjust this. You can see my needle go up. I'm going to bring this close to 50. The warm-up period is about 10-15 minutes, so I'm going to let it warm up. See, I had it set at 50 and now it's climbing up all the time, so we'll let this thing warm up, and we'll check both, and then we'll do the left channel after we're done with this. Okay? And there's the milliamp, a little over 50. just got it a little below 50. Well, not really below, it's right bang on. I would say that this is pretty much set. The warm-up period has been, you know, well over 10 minutes. And at 50 milliamp across the fuse gives me 22.3 millivolts across the emitter resistor. You know, if you don't have an amp meter, then you can also use your millivolts and say, well, you know what, if I set this to 22.3 millivolts, I should get 50 milliamp across that fuse. So, you know, should be cool. I'm going to shut the power off. What I want to do now is I want to transfer everything to the left channel, okay? But I feel safer by shutting this off because I don't want to be shorting anything while I'm doing this. Anything can happen, right? So I think you're safer if you shut it off. All it is, it's time consuming because you have to let it warm up again, but yeah, I got all the time in the world. The fuse back in there. Take my clamps out of here and I'll put him for the left channel. There you go. And I'll remove this fuse. And I'll be checking. I do have polarization and I have to make sure that I have the right polarization. So this is the plus and this is the minus. So minus goes here. Plus goes here. And I'll just use my piece of tape for precaution. Okay. There, I'm all set for the left channel. Now, what I'm going to do is I'm going to power this on. There you go. Okay, so following this again, we're doing the left channel. I've removed the fuse. I've hooked up my amp meter on the fuse terminal. And what I've done was I'm going to measure across the emitter resistor with my multimeter. Then we'll compare. This one here was 22.5, I think. We'll compare this one. Okay, I'll zoom you guys in. My millivolt is, I'm showing about 30 milliamp, and across my emitter resistor I'm showing 7.7 millivolts. So we need to adjust this, and we shall bring this up to 50. That's about 50. And I'm showing 23 millivolts across the emitter resistor. Yeah, I've passed 50. We'll have to kick this back a bit. There, that's about a 50. We'll see how that works out compared to the right channel. The warm-up period is still in effect. I still have about 5 minutes to go, but it'll be okay. So you guys can clearly see milliamps, eh? That's a 50 milliamp right there. and I'm at 22 or 21.8. It's close. The other one was 22.3, I think, eh? But this is not. Yeah, it's a bit below 50. I'm going to let this warm up still a little bit. But this is how simple it is, and basically all I wanted to show on this video was an ammeter is what I was supposed to measure this, and which I did. I measured it with the milliamp into milliamps, which they wanted 50. But I wanted to show as well across the emitter resistor, what would I be getting if I get this at 50 milliamp? What would I be getting as in millivolts? And say bring it up to 22.5 and say, well, 22.5 should give me a 50 milliamp across the fuse, and you would be safe with that. So that was a question they're asking online, and where would I set the idle current? So I'm happy with this. The right and the left channel is equal, 22.2 on this one. The other one was 22.3. It is set to, according to the service manual for this Luxman. And I'm going to power this off and move on to the next step. Okay, this stage here is 1000 hertz of frequency going through my auxiliary. It's going to go through my scope, through an 8 ohm resistor, and we're going to measure distortion, and we're going to measure how many watts per channel I'm getting with this, and this is rated at 55. Let's do it. There it is. It's coming up. Halfway, it's at 2.4 RMS. I have distortion here, so I'm backing it up, and I'm getting 22.4 RMS on this. There's my distortion, so I'm going to kick this back right there at 240. So I'm going to kick this back. So this is just beautiful. Alright, 22.40 RMS on this, so we'll add this up for you guys. I know this is over 60 watts per channel, and this is only rated at 55. I can get a good 5 watts per channel more without distortion with this thing. This is running flawless. Now this is powered on, and I'm gonna set the bulbs. The light bulbs are working okay, but I feel that somebody was playing with those, and they didn't put them far enough in. Like if you look at this, see how better lit up it is? Because before it was like this, wasn't getting anything. But if I push it in a little further, so it's going almost halfway, and that's what I want. I want this one to go about to here, and this one will be set to that. So I'm thinking this is a lot better. I just need to set this one. And then I'll do the same on this side. See what I can do with this. There, that's a lot better. The whole servicing of this Luxman is all done. Now, I'm going to play some music.
Can I tell you, I'm happy to be here to share and consider.
There, the receiver, Luxman R1050 is fully serviced from A to Z. From the lighting to the bias was a bit of a challenge, but we managed it. This Luxman had a good reputation back then, and I think it still does today. It really does sound amazing, and 55 watts per channel. This thing can kill a little bit of noise in your living room. It's definitely worth owning and worth restoring. So anyways, if you like the video, thumbs up and subscribe to my channel. I would really appreciate it.